Hello. So as Daniel mentioned, I run the LIDG group at the Apple, which is run in the Apple Store. Currently on the first Wednesday of the month, except for next month because it will be the first, and I'm not expecting anyone to be remotely awake by the end of the day to come to an iOS event. So if you're in London, look us up. It's the London iOS Developer Group. We're at the Apple Store, so you can just come along. There's no registration. And if there aren't enough seats, you can stand or sit, or you can bring your own seat maybe. Apple will just tell you no if you'll go too far. I don't think they'll be able to get the couch up the staircase. I should really talk about my talk now, rather than promote my stuff. So compiling data. We kind of heard towards the end of that last talk, to segue nicely into my talk, why you might want to compile data. And I'm not talking about compilation in the way of going out and data mining or doing questionnaires on the street. I'm talking about having some form of data and transforming it into a more usable version of that data. So you might, for instance, have a nice vector PDF image that you realize renders really slowly on the device. So you want to compile it into a raster image, a bitmap image that you can use in the app. You might also have a client that thinks he's very clever and gives you a ton of HTML files because he's technical. He can give you HTML files, and you don't need to do anything to them. So you just put those in the app, right? I'd rather just have it as text and style it myself. And you realize that the web view is rendering a lot slower than text views these days, and text views can do a lot. So actually, the HTML doesn't mean a lot to you. So you end up in this situation here, where he's given you everything in the world, and at runtime, you have to run it and display an app. And this takes kind of forever. You notice how slow that was? I'll get that again. So we're kind of waiting around for it to all parse because this is just an iPhone, which is really slow, which would have been true maybe 4 years ago, but it's actually quite fast. But either way, the iPhone is still slower than the computer that you're using to run, and it's slower than just having a better data format when you run the app. So upon realizing this, you're kind of clever, and you realize that what you can do is actually make a parser do the work for you, so that you can have your, say, all this mangled data. You're like, I'm serious here. I got a project with over 1,000 HTML files because he decided that they wanted a page to be represented by a page of HTML. And this was fine, and then he realized that each page needed to be a table view cell as well, because he wanted an index with some of the content coming from each of the HTML files. You really can't do that, and if you can, it's still faster to do it this way. So being clever, you'd write a parser that gave you the SQL, in this case, SQL database for core data, and then you'd kind of copy that in maybe into your iOS app, and it would launch a lot faster. In fact, instantly, with all the data. Of course, it's not instant, but for timescales. The problem here is that your client is technical, and he's going to go away and edit all those HTML files or redo the images that you want to cross-compile and put into a different format or correct the sizes. And at this point, you've got a SQL file which is fairly unreadable compared to a load of very readable HTML files. After all, this is the reason he's done it in HTML, is because they are readable. You've also got the other problem of having the SQL in your repository. So you're building off something else rather than the actual source files as they were. I see these as kind of source files. So anyone else coming into the project would think that those source files were the ones actually getting displayed in the app. So if they try to change something and wouldn't see an update because they haven't done this parsing step. And you could put something in the README that says, make sure to run this parser every time you change these files, but no one reads readmes, okay? No one does. Mike might be the only person in the world to read a readme. So you want to do something like this, where as you build, the parser gets run, it generates the SQL, and then is put into the app bundle, which is what I'm going to talk to you today about. We want to take in this client editable data. You could do anything here, right? You can put in any source files and transform it so that we can get faster launch times at the end. We want to take these thousands of HTML files and the XML that he's presented to us, and generate something that we can just put in the app that gets run on launch. And it's worth saying that it can't be any data that you want to change later on, or it could be. It could be your source API, right? So it could download the initial batch of information from an API that you would then update later on, just to give you an initial hit of data. It does depend on whether that data is time sensitive, I guess. So what we're going to do is build an OS 10 command line tool, which can be found here in the OS 10 application, I don't know what this area is, group, I guess. And has anyone ever done a terminal app? Because if everyone's done it, I'll walk off now. But if no one has, excellent. I've done stuff like this before where I've done the second method, where I have generated the SQL and then bundle it in. And the other problem is that you will forget to do it, and you will forget how to do it. So if the client comes back with new source, because you're not constantly doing it, it's not part of that process, you'll be like, now I've got to build that, and that's going to get put in the derived data. And where's the derived data on this machine? Because I'm using some non-standard folder, and you've got to go find it. And then it might not actually be the right one because you might have built the bug and then release at the same time. So you've got to find out which exact one it is. This is by far the best approach, just to streamline that whole process. So the command line tool is basically an executable that we're going to run from the build phase to parse the data in a way that we want and output it. What this means is that we can put anything into it and do anything that we can in a normal Cocoa app and get something out at the end. It knows about core data so that we can directly manipulate a model, store and a model. However, the command line tools don't have a bundle, so you have to provide a bundle to them. So iOS apps get a bundle by default. They are a bundle themselves. The executable is inside, and then all of your assets get put into the bundle so that everything is loaded from that bundle. If the executable doesn't have a bundle, then it's got nothing to work with, per se. So you need to provide all of the information to it about locations up front. And because it's a command line tool, we'll run it and we'll just provide them as flags. It's worth noting that the different types of actions will provide different locations for where your build goes. So we're going to build a bundle ourselves and provide that bundle to the tool. And depending on what you're running and other people's machines is obviously going to be different. Their derived data is not going to be in the same location as yours, unless everyone's username is the same. But even then, they might have moved it, because you can. Between debug and release builds, the paths are different, and if you're doing an archive, it's wildly different. So it's best not to assume anything, and you get these all from Xcode. They'll give you all these locations. So if you've never got involved in making a bundle, because it's quite rare to need to do so, a bundle is basically a folder with a plist in it that's named .bundle, and it has a load of anything in it, really. As far as I can make out, I don't think there's anything more special than that to it. But there is a target for it, and what this will mean is that when we're going to put the model inside the bundle, so that when the bundle is built, the model is compiled in the way that we expect, and we can then put the SQLite store into the bundle, and then the bundle will get copied into the app. So when you make the bundle, you notice that it was actually an OS 10 bundle. You can't make a bundle for iOS, but the way to change that is just to change this to the latest iOS as the base SDK, and then it becomes an iOS bundle. I'm not overly sure why Apple don't give just a default bundle for iOS. I'm not overly sure. I generally, the other times I use bundles is when I'm creating a static library. So if I create a static library for a lot of code and I need images with that library, then I'll create a bundle alongside it. And I think Hockey App does this as well, to include all of those images. So like I said, there's the hardest bit about this whole process is knowing the setup. It is knowing what to prioritize in Xcode to make things work in the right order. So we're firstly going to build the bundle before we build the parser, because the bundle needs to be given to the parser. Then we're going to build the parser and give the bundle, and when we run so we're going to build the bundle and the parser before we build the iOS app. And when we run the iOS app, when we build this, we're going to run the parser with the location of the bundle. If that makes sense. I should have built a better diagram. This is not the way to destroy this information, is it? And at the end of that, under running the parser, we're going to copy the same bundle into the app. So we can see here that we're on the parser target, which is the command line app. We're going to make the bundle a dependency. And it's worth saying that this project's on GitHub, so you can download it and follow along. You do need a Wi-Fi or internet connection to actually build it, but I'll go through that in a bit. And again, with the app target, there's a dependency of the parser. So this all kind of chains together. And this is one of the problems we have with the build location, is that the parser's getting built into debug. If you're doing a debug build, if it's release, it's release. It's not the same location as the iOS stuff, because the iOS stuff gets postfixed with iPhone OS or iPhone Simulator. So what we need to do is copy the parser into this folder here, because both targets will know about this folder. And this turns out to be build root in the Xcode environment variables. So Xcode gives you loads of environment variables telling you where things are going to get put. Those are the things that you should use to do any scripting in Xcode with. Because if they decide to change them, or if they're slightly different between versions, those are always going to be right. And that looks like this here. So at the end of the parser being built, the last step, we're just going to run a script to copy from the executable path to the build route. And then in the application target, we have a script to run the parser. This happens before we compile any of the other sources and copy any of the other stuff into the app. So we know that the bundle is there and it's ready to be used. And the script for doing that, made it a little bit bigger. We're going to locate the parser. So we know it's at the build route, and it's called the alt-tech-talks parser. We know the bundle's going to go into this configuration build directory, which is the iPhone's build directory, because we made it an iOS target. And we've named it the alt-tech-talks bundle. And then we're literally just going to run the parser with the bundle location by giving it the flag -b, -b. This library makes everything possible, really. It would be possible before. When your app gets run, main gets run with the arguments that you pass in. But this thing called DD CLI, which is command line interface, helps you parse all the options that you get given, and will give you a better structure to the app. So it'll actually more mimic what we're used to on iOS and Mac with an application delegate. And once you've got an app delegate, we all know that we can just dump all of our code into that. And you'll find that actually writing a parser is really easy, because it's just that one class. And you don't even need to keep referencing the app delegate from other sources, because you're just using the app delegate. Put all of your code in that app delegate that you get. So this library is written by Dave Driven, who is now at Apple, I think. He was. And it's used in MoGenerator. And it's probably used in loads of other places that I don't know about. And this is where I show you the app. I might have to go on that side. So does anyone have any questions? Yes.
Just when you write a command line tool, did you consider just using the standard Unix file as standard in and standard out, and you could then just include it and mix it with grep and all the other weird and wonderful command line tools from Unix, rather than building something which is like a headless Windows app, effective Windows app?
So the question is, did I consider just doing a normal Unix app rather than
for the past,
a fully?
Yeah.
The first thing it allows you over anything else is that it gives you the structure of an Objective-C app. So you get all of the Objective-C goodness that Graham was talking about, and we're not writing, I don't know, we're not going around in the dirt. We're up here on our pedestals in the nice world. The other reason is that only by writing a Cocoa app can you access core data. So if you're parsing to core data, that's the only way to do it, as far as I'm aware.
Yeah.
This is right.
I'm afraid we can't take any questions after that, but please.
Oh, okay. Can everyone see that? That's. You won't believe how hard it is to see it on this. Okay.
Can we get the screen reader switched on?
All the code will be better. Unfortunately, I've got the zoomy thing. So, like I said, we've got a bundle here, and let's see this. Right. So in the bundle itself, in this app, we've got the model, and the model's just got one entity of a speaker, and we can see that. So this isn't a very complex demo. We're compiling the model into the bundle itself. And the parser has these sources, which we'll go look at. And it's got a dependency of the bundle. So the bundle's going to get built before the parser is. And the application has a dependency of the parser. And it's got all its other bits. Interestingly about this is that the bundle is getting copied into the resources of the app. And the model isn't. So the model is already in the bundle, so we don't need to include it again. That adds some trickiness later, but you could compile it again, I think. I don't know if there would be any problems with that. There'd be the same model. if we look at the parser first off, is that better? Okay, so DDCLI, I'm not sure if there's a fast way of saying that. You can run this command line app with a default class. So here I've got the Alt Tech Talks parser, not the AT&T parser. And that basically gives us a framework to work in. And this delegate here gives you some stuff which looks fairly similar, like application run with arguments. And this one here, application will parse options. We can have a look at that. So this is where we set what options we want to look for when we're running the command line. So we could put in a long option of bundle instead of just putting -b. What this will do then is add the options that it finds from the command line when we run it on the command line to our parser, and we just declare them as properties. So we've got the bundle here, which is the bundle string that we passed in to the command line app. So like I said, we're just going to dump all of our code in the app delegate, which is this bit here, which is going to do our parsing for us. It's worth noting that I've got this Alt Tech Talks thing here, which is going to give us the bundle. We've already got the bundle, so the bundle location, so we're going to load it from that. This is for when we're running from the iOS app. It's probably wise to put stuff like this, to make a model URL and a store URL given a bundle. That way you're only using magic strings once. So if these change, it's all okay. And we're going to store all of our data into a SQL store called data.sqlite. And that's going to be put in the bundle. So what this app does is create a core data stack with the model URL and the store URL. We're going to load up the Tech Talks webpage, and we're going to parse that for all the information that we want. So we're making an Alt Tech Talks app. Okay, and like all good apps, we're just displaying exactly the same stuff that's on the web page, but a little bit faster. It's also worth noting that because we're on the Mac, we can use stuff like NSXML document, which is a lot easier to do parsing of XML. So it will automatically tidy the HTML for us. So if it's slightly broken, it'll tidy it up as best it can. And then we can do XPath queries on it. So actually, apart from being faster to launch, we get a lot more options on how we parse it, a lot easier options, without having to include other libraries that might want to do this. And then we're going to go, so we're going to find all these talk nodes under the UL of media list and the LI of media, and then go through all the nodes, find the image tags there, get the source, put those into a location, and then download the image, store them in the bundle, hash a file name, and put the file name onto the core data speaker entity object that we've got. So that's us downloading the image, and then we're going to get the details from the talk. So we're going to get the name of the talk, the name of the person speaking, and their kind of bio. At the end of it, we're going to save and return 0 for a good, clean exit. And this is my view controller, which is coming in at 73 lines. So I'm onto a winner here. I think this is going to be a fantastic app because of that.
There's an S at the end of the, see the AT&T speaker, got HS is a syntax there. Is that syntax there? Yeah.
No, that's not there. So this is where we use the bundle in the Alt Tech Talks, and this is probably worth having a look at. It's nothing fantastic, and I'm sure there's probably a better way of doing it. I iterate through the contents of the main bundle looking for something called alt-tech-talks-bundle.bundle. So I'm basically searching the bundle for our bundle, which is the one that includes the store and the model. And once I've got that bundle, I then get the URL for the store and the URL for the model. It's a read-only store that we're context that we want to do because it's in a read-only location. We pass those options through to make our stack and grab a context, request all of the speakers and sort them by their attribute names, and then display them in a table view. Because that's what you do. And hopefully this is just regular stuff. And there's also a speaker detail. That's all regular. So when we run this, what's happening here is it's going to the internet and downloading all that stuff afresh. And we see there that we've instantly loaded up with all the data. And just lastly, I'm not going to be able to find it now, am I? One second. I should have loaded this up beforehand. So we can see here that our parser has been moved to the root of this structure so that we can actually use it. And then the simulator here has got the bundle. If we show package contents, it's got all of the... This was just the easier way of doing it. I just base64 encoded all of the names to get kind of unique. I initially ran a unique string, and then I realized that every time I built it, it was downloading it, and this file was just getting huge because it was downloading all of the images again. So you've got all the images here of the speakers, and then the SQLite for the actual store is here, and we can see the compile model is here as well. So it's all kind of put into a place where we can use that, and hopefully really speedily. That's not what I want. So you can find the demo application there. There are a few takeaways with this. First off, and I can't believe I'm about to revise this, but when you're writing a parser, you want to block the thread, right? It's like the thing we never ever do. But because we don't want the parser to finish actually running, we want to stop it. We want to stop the thread that it's running on. So all of these calls were sending synchronous requests, which I think is one of the only times I can suggest to actually use this method. This is going to block the thread, stop the parser from returning, and then stop the build phase from going. This also means that if you download this app and try and run it on the train like I did on the way here, it fails to build. So actually downloading stuff during a build phase is probably not wise either. So, but yeah, this is a demo, which I thought would go quite well. Oh, that's it. Thank you.